Yes.
Okay, thank you. All right, guys, so we're talking about solving basic trig equations. Everybody in here knows how to solve an equation. If I said to you right here, this first equation, I would just rewrite it. I can change this to make you guys see it a little better. If I said x squared plus y squared equals 1, what do you notice about the variables in that equation? They're the same or they're different? They're different, right? X squared and y squared. So you can't solve for one of them without knowing what the other one is, or changing them all into the same variable. So same thing goes for right here, where you have sine squared and cosine squared. And this will make more sense in a minute as we go through. This right here, I could say that this equation is the same as saying 2x minus 1 equals 0. How would you solve that if it was 2x minus 1 equals 0? You'd add 1 to both sides. Good. So add 1. So you'd have 2x equals 1. Then you would do what? Divide by 2 and get x equals 1/2. Everybody agree with that? All right, same thing goes for here. This is your quote-unquote variable, your trig function with the theta. Anything that is outside of that, being added, subtracted, multiplied, divided, whatever, you get rid of. So if I was going to solve this, I would add 1 to both sides, then divide by 2. You guys agree with that? So you'd be left, you'd be left with sine of theta equals 1/2. Okay, if I come over here, here's my trig function. I'm going to always tell you guys to highlight, highlight the trig function. Yeah, there's a 2 in front of it. We'll talk about that a little more tomorrow. But what would you do to get tangent to theta by itself? It says minus 1. How do I get the 1 to go to the other side? Add it. Okay, so same concept. You guys all know how to solve equations. So let's go through some of these examples. And we'll be good to go, I promise. All right, we're talking about trig, trig equations. The reason this is a trig equation is because it has a trig function in it. All right, we're going to be using our unit circle. What I do need you to remember is if I have an ordered pair, I have an x and a y, right? The x value is what trig function? Sine, cosine, or tangent? We don't remember. Okay, x value is our cosine. Y value is what? Sine, cosine, or tangent? Sine, good. And then how do I find tangent? Is y over x. Okay, we need to remember that. We're not going to reteach, guys. It might refresh your memory, but we're not going to reteach. So your x value of the ordered pair is cosine. The y value is sine, and your tangent is y over x. And the reason that is important is because this is what you're going to be asked to do. Solve the trig equation. Every single time you have a solve the trig equation, the first thing I want you to do is rewrite the equation. So I'm going to rewrite this as the sine of theta equals 1/2. Okay? Everybody with me? Now, sine of theta is our variable. So I'm going to tell you guys to highlight the trig function. Anything that is being added, subtracted, or multiplied, divided by that. Right? Nothing is. There's nothing being added, subtracted, nothing. So all this is saying is, where is the sine of theta on the unit circle 1/2? This is how you would answer this question. Sine is the same as what? X or y? What value? Sine is the y value. Yes? We just talked about that like 2 seconds ago. So sine is our y value. So we're going to go to our, to our unit circle and find where all the y values are what number? 1/2. So come over here. This is 1/2 right there, positive, pi over 6. This is 1/2, positive, 5 pi over 6. That is your answer to this question. Pi over 6 and 5 pi over 6. You solved an equation, which you've done since you were in 8th grade. You determined which value you're looking for, the x or the y, because it's the sine. Then you find the corresponding values on the unit circle, and that is it. I promise you. It does not get any harder. You have to use your basic solving equation, skills, but it does not get any harder than that. We okay? All right, let's look at the next one. What's the first thing I asked you to do? When we solve these, what's the first thing I did? Rewrite it. Good. So I have the tangent of theta equals 2. Now you can always find these things using a calculator, but we're not using a calculator. We're just worried about, you can use one on the quiz or test, but we're just worried about finding stuff on the unit circle. So follow the steps that I did. We're going to isolate our trig function, right? Is there anything being added, subtracted, multiplied, or divided to my tangent theta? Nope. So then I'm going to remind myself, okay, tangent is what over what? Y over x. Awesome, guys. Now, this is how you would show me your work. If I don't see any work for these problems, you're not getting credit. This is how you're showing. Math way doesn't do it this way. So if you do it the math way, I'm not giving you credit either, and I will have no problems telling you guys that. But I'm looking for where on the unit circle the tangent value is 2. So I take the y over the x. Now, I'm going to give you guys a little hint here. What do you notice about all of the ordered pairs around the unit circle? Okay, denominators too, agreed. Look at the first quadrant versus the second quadrant. Look at the ordered pairs themselves. Are they similar? Yeah, they're exactly the same all the way around. Just what's the difference? The signs, right? You have 1/2, root 3 over 2, and root 2 over 2. Just depending on where they are, as if they're positive or negative. So instead of having to do the tangent, every time you have a tangent problem, you have to work out all the tangents. Let's go through just the first quadrant, and let's figure out all the tangents and write them down so we don't even have to think anymore. So watch what we're going to do in the first quadrant. Up here at pi over 2, I would take my y value and put it over x, right? So tangent here is 1 over 0, which gives me what? What's 1 over 0? It's undefined. So your tangent right here at pi over 2 is undefined. You'd say tangent, you could say undefined. Okay, so I go down here, I'm going to go to 60 degrees. You guys, it's y over x, right? So root 3 over 2 divided by 1/2. When I work that out, I get root 3 over 2 times 2 over 1. So what is the tangent, guys, right here at pi over 3? What happens when you have root 3 over 2 times 2 over 1? What's the tangent? Guys, root 3 over 2 times 2 over 1. What happens to the 2's? They cancel out. So your tangent here, when 1/2 is first as your x and 3 over 2 is second as your y, your tangent's root 3. So here at pi over 4, when your ordered pair is root 2 over 2 comma root 2 over 2. So your tangent would be root 2 over 2 divided by root 2 over 2. What is this? Anything divided by itself? Not 0. 1. So the tangent at pi over 4 is 1. Here, you would take 1/2 divided by root 3 over 2. 1/2 times 2 over root 3. What happens to my 2's? They cancel out. Then I have to rationalize, right? So that gives me root 3. Here, the tangent is root 3 over 3. Excuse me. And then here at 0 degrees, I take 0 over 1. So it gives me tangent of 0. Now, why is this important? Why did I just go through that? You guys are like, oh my gosh. So you don't have to work out the tangents every single time. All you got to do is look at the ordered pair. If I said to you, what is the tangent down here of 5 pi over 4? You don't even have to think. Look at root 2 over 2. It just happens to be a negative and a negative. So a negative divided by a negative gives you a what? Positive. If I asked you right here what the tangent was when root 3 over 2 is first, well, go to your ordered pairs. When root 3 over 2 is first, what's the tangent? Or you can just work it out every time. But if I had root 3 over 2, comma, negative 1/2. We'll look at it in the first quadrant. When root 3 over 2 is first and 1/2 is second, your tangent is root 3 over 3. But since it's in this quadrant, one of your coordinates is negative, so your tangent would be negative. I'll explain this a little more when we go to the next example, but that is something that you guys should either memorize or write down. You should know in the first quadrant whatever the tangents are, and then you can just look all the way around. It's super easy. But in a case like this, the question says, where is the tangent of theta the number 2? Is there anywhere on this unit circle where you would find the tangent of something is the number 2? Yes or no? No. So you guys would say no solution. That does not happen a lot, but it does. So I want you to be aware of that. Does not happen a lot, but it does happen. So please just be aware of that. All right. Now you can find the tangent of 2 using your calculator, but we're not doing that. We're just finding based upon our given unit circle. But I want you guys to understand the unit circle is a pattern. So here at positive 1/2 root 3 over 2, this ordered pair right here is the same as this one. The only thing that's different is there's a negative. So if the tangent at this point is positive root 3, what is the tangent over here? Negative root 3. So down here, when negative 1/2 is first, what's the tangent here when both of them are negative? A negative divided by a negative gives you a positive. So over here, when 1/2 is first, one is positive, one is negative. What is the tangent? Negative. If both x and y are negative, then your answer is positive. If it's one of each, then it's negative. Let's go to the next one. We got 2 here. All right, we have A. Let's do A first. What's the first thing I told you guys to do? Rewrite the equation. So I have 2 times the sine of theta minus 1 equals 0. Now I'm going to highlight my trig function. Is there anything being added, subtracted, multiplied, or divided here? Yes, so you got to get rid of it. How am I going to get sine of theta by itself? Add 1. Plus 1, plus 1. So I have 2 times the sine of theta equals 1. Is that by itself yet? If you don't see it, highlight it. What would I do now to get the sine of theta by itself? Perfect. Divide by 2. So I have sine theta equals 1/2. So this question is saying what? What does sine mean? X or Y? Y values. I'm looking for where on my unit circle that the Y values are 1/2. Go over to your unit circle. Where are the Y values? Positive 1/2. Positive 1/2. Y values. Pi over 6 and 5 pi over 6. Perfect. There's your answers. Pi over 6 and 5 pi over 6. Nothing about this is, oh my gosh, so hard. But if you guys are sleeping, you're watching TV, you're not paying attention, yeah, this is not going to be a great test for you. But there's nothing else I could do. I'm giving you the unit circle. There's just nothing else I could do. All right, let's look at B. First thing we do, we rewrite it. Good. So I have tangent squared theta minus 3 equals 0. Highlight your trig function. How is this one a teensy tiny bit different? It's squared. Okay, no big deal. If I had x squared minus 3 equals 0, how would you guys solve this? You'd add 3 to both sides. Perfect. I add 3. I get x squared equals 3. Then what would I do? Take the square root. Same concept. Is my tangent squared theta by itself? No. So I'm going to add 3 to both sides. So I have tangent squared theta equals 3. Now what? I take the square root of both sides. So I have the tangent of theta equals the square root of 3. When I physically put the square root on, what goes in front of my answer? Plus or minus. Remind me again, please, guys, what is tangent? What over what? Y over x. Now, I want to know all the places on the unit circle that the tangent is just the square root of 3. This is why it's super helpful for you to know what the tangents are on your unit circle. Go back to what we just did. Right here we said that the tangent at 0 is 0, right? Up here, the tangent was undefined. Here, when my ordered pair is, excuse me, the two same values, your tangent is 1. Which ordered pair, guys, will give me just root 3, not root 3 over 3? Pi over 3? Is this one up here root 3? And then down here, tangent is root 3 over 3. This is something I think is really, really helpful for you guys to either memorize, write down something, because now I want to know all the places on the unit circle that give me positive or negative square root of 3. So it's here. Where else? Where else has the ordered pair 1/2, comma, square root of 3 over 2, regardless of the sign, because I want positive and negative. So where else? 2 pi over 3, good. Where else? Which one goes 1/2 root 3 over 2? What is it? 5 pi over 3, agreed. Where else?
4 pi over 3.
Perfect. So your 4 answers here, and we have 4 because it's plus or minus. Your 4 answers would be, tell me again, pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. So pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. What do you guys notice about those answers? They all what? Same denominator? All right, there'll be a common theme when you have something like that. Now, the reason that it's good to memorize this is because you don't have to waste time finding the tangents of every single thing on the unit circle. You just know, hey, it's a pattern. It's going to be the same thing all the way around. Just have it written down. Have it in your brain. Questions? Oh, jeez. Just when she says it's not going to be that bad. All right. What's the first thing I asked you guys to do? Rewrite. So rewrite it, just like I said. 2 cosine squared theta minus, whoops, forgot the minus, 7 cosine theta plus 3 equals 0. Now you guys are like, oh my gosh, why does she change stuff all the time? How is this a tad bit different? There's 2 cosines. One of them is squared and one of them is not. All right, if I rewrote this, just one simple change, you guys would be like, oh my gosh, we've done this forever. If I wrote this, I want a different color. Can you guys factor this? Yeah. You do a times c, right? Which will give you 6. What are the factors of positive 6 that multiply to give you 6 but add to give you negative 7? Negative 1, negative 6. Good. Since my a term is not 1, I have to do a little magic here, right? So this becomes 2x minus 1. And this becomes, whoops, x minus 3 equals 0. Guys, this is just a quadratic equation. You have 2 trig functions that are the same, right? So you factor it. Whenever you see a quadratic trig equation, if it was sine squared and sine, same thing. Tangent squared and tangent, same thing. Just turn it into a basic algebra equation that you guys have seen since 9th grade. And now, to solve this, what do you think I'm going to replace the x with? Cosine, because that's the trig function that we're using. So this says 2 cosine theta, I'll put it back to theta, minus 1, and cosine theta minus 3. Same exact concept, just your quote-unquote variable changes, right? Your trig function is just, you can look at it as a variable. You guys know how to factor equate. You've done this forever. So now what do you do when you solve, right? We take our two parentheses and we set them equal to what? 0. So I have two little equations here. I have 2 cosine minus 1 equals 0. And I have cosine theta minus 3 equals 0. Okay, I'm going to start on the right-hand side. A lot of times, guys, both equations will work. For whatever reason, the problems that are in here, one of them doesn't work, but that's okay. If I want to get cosine by itself, I'm going to add 3, right? So I have cosine theta equals 3. Well, remind me, what is cosine? What value is on the unit circle? X. X values. We got to remember that. So think about it, guys. On your unit circle, where are the X values positive 3? See it anywhere? Because it doesn't exist. So this would be no solution. You could just cross it out if you want. That tells me no solution. Now, a lot of times, both of them don't cancel out or one of them doesn't cancel out. It just happens to be like this. So now I'm going to go over here and I'm going to say, all right, I want to get my cosine. Whoops, I forgot my theta. I want to get cosine theta by itself. So what do? Add 1. So I have 2 cosine theta equals 1. Then what? Divide by 2. See, a second ago, you guys were like, oh my God. Now it's super easy. What's cosine again? So what are you really asked to do here? God bless. Never mind. Did you sneeze or was that a hiccup? Okay, bless you. What is this question asking? Cosine theta equals 1/2. What do you need to look for? X values on the unit circle that are perfect. So here at pi over 3, and where else? Pi over 3 and 5 pi over 3? Where my X value is 1/2? Perfect. So your answer here would be pi over 3 and 5 pi over 3. Now, a lot of times, both of the equations will work, so you'd have 4 answers. This case, it doesn't. But all you're doing is solving basic equations, which you know how to do. Change them all, if you want to variables, and then just put your trig function in at the end. It should not look scary or anything like that. All right, the last one. Then we're done. Oh my gosh, here she goes again with all these crazies. First thing I do is what? Rewrite, correct? Now I'm going to do some highlighting just to bring some things to your attention. Here, I got a sine here. I got some cosines here. So now what? You guys are like, oh man, the last ones, all of them had the same trig functions, right? So let's just think for a second. If I said to you guys, why do I keep doing that? 5xy plus 4x equals 0. And I said, okay, guys, solve this. What's the first thing we look for when we're factoring? Like terms, GCF, what do they both have in common? We would take the x out, and then we're left with 5y plus 4 equals 0, right? Set each equal to 0 and go, correct? Same thing, guys. What do they have in common here? The first term is 5 sine cosine. The second term is 4 cosine. What do they have in common? They both have a cosine. So if I divide out a cosine theta, my math rules do not change. I rewrite cosine theta out in front here. Then I'm left with 5 sine of theta plus 4. Agreed? Equals 0. Now what do I do with the two pieces that I have in order to solve? I set both of them equal to, okay, so cosine theta equals 0. 5 times the sine of theta plus 4 equals 0. Now, guys, can I give you like 20 of these on a test and expect you to finish them in 45 minutes? No. So the more work you show, say this is a 25-point question, I'd say you've earned at least 10 points by showing me that you can factor out the cosine, that you understand to split the two and set them equal to 0. So the more work you can show me, the way that I've shown you, not the way that Photomath and all of your other helpful tools, the way that I'm showing you. Solve this. Cosine theta equals 0. What does that mean? Tell me what that means. Cosine is what value? X. So what they're asking you to do here is go to your unit circle and look where? x values that are, okay, so look, where are the x values 0? Pi over 2 and? Awesome. We're talking a little more because this is making sense. So pi over 2 and 3 pi over 2. Fantastic. All right, same thing. We're going to come over here. Is sine theta all by itself? Well, we need to get there. So we're going to subtract 4 from both sides, right? So 5 times the sine of theta equals -4. Divide by 5. And I'm looking for what on the unit circle? What sign? Good. Sine is our y values. I'm looking for what on the unit circle, my y value, is -4/5. Anywhere? No. So what can I do here? Just cross it out. I can say no solution. Either way. But just say you get to this part, you get here and you forget to cross it out, or you find an answer. I can give you 18 out of 25 points because you got through the process. I'm not solely concerned on what the final answer is. The more work you can show me, the more brain power you can show me, the more thinking that's logical that you can show me, I can give you partial credit for. But if you just don't do it, or put IDK, or a question mark, there's nothing I can do there. Comprende? All right, guys, I'm going to upload this video now.